going to make the basic function y equal 2a to the x, and then we're going to let 2 to the x represent it, because that's easy enough to do. The domain of this guy is all real numbers, and you're going to say, well, why would that be the case? Well, no denominator, no radical, so it would be all real numbers. And if that's the case, I'm going to go -2, -1, 0, 1, 2, and I actually will go 3. This would be 2 to the -2, which would be 1 over 2 squared, which would be 1/4. 2 to the -1, which would be 1/2. 2 to the 0, which is 1. 2 to the 1, which is 2. 2 to the 2, which is 4. 2 to the 3, which is 8. So that at -2, I'm at 1/4. At -1, I'm at 1/2. At 0, I'm at 1. At 1, I'm at 2. At 2, I'm at 4. And at 3, I'm off the paper at 9. Somewhere up there. And then if I connect the dots, this is what's happening. This guy's going to continue to go up forever and ever and ever. Now, what happens is this. No matter what I put in as an exponent, if I had 2 to any negative power, this is 1 over 2 to the positive power, and it's a positive number. 2 to any power is going to be a positive number. So that means that the bigger that this number gets, x gets as a negative number, the smaller y gets, and what I have really going on is a horizontal asymptote. And so I have a horizontal asymptote at y equals 0. It'll get smaller and smaller and smaller and smaller. So I'm going to go under y equal to the x. And I'm going to go into something called table. I'm going to set the table to start at 10, and it doesn't matter how I increment the table. I'll increment the table by 100. So that says x starts at 10, the next one will be 110, and then 210, and then 310, and so on. This may actually be a little bit too fast, and get a table up. And what you notice is, see, this came down too fast. So I'm going to go back in and reset that table, and I'm going to increment them. This is going to be by negative 10. So now it's going to be 10, 0, -10, -20, -30, and so let's see how this is going to go. And very, very quickly, notice e to the 4th, -4, by the way, what that means is this. This is approximately 9.8 times e is 10 to the -4. That's scientific notation, which is 0.12398. So it's going to have, but that's a 4, there are 3 zeros in front. If I come down, that's a 7, there are 6 zeros in front of that 9. I come down here, and this is x to the -50. You notice there are 15 zeros in front of that 8. That's getting very, very close to 0. But it doesn't matter. I'm always coming up with a positive number. So here I am at -240. Now it's 5.6 times 10 to the negative 73. There's 72 zeros in front of that 5. It's always a positive number, but it's getting closer and closer and closer and closer to 0. So that's why we can say it has a horizontal asymptote at y equals 0. It doesn't ever cross it, because it's never 0. There's always something there. That means that the range is going to start at 0 and not include, and then go off to infinity. So it's going to be 0 to infinity. And this becomes critical when you start doing transformations. Because remember what you're doing, you're transforming the basic function. And all the basic functions will look like this. Their domain will be all real numbers, their range will be 0 to infinity. Their domain will be all real numbers, the range will be 0 to infinity, and they will have a horizontal asymptote at y equals 0. This is your basic function. It's your basic function. Therefore, when I want to start to graph using transformations, the first thing I have to do is I'm going to have to rewrite this function. This is not the way we're used to seeing it. We're used to seeing the function in front. The function is the exponential function. So that this becomes f of x equals negative 2 x to the x plus 3 plus 1. That's the way we're used to seeing it. We're used to seeing it with the function in front and then the constant in the rear. That gives me that the basic function I'm dealing with is y equal to 2 to the x. We know his domain is all real numbers, and that he has an HA at y equals 0. That has to be taken into account. Now the basic function is being transformed, and I will start, of course, always where the x lives, and that's an x plus 3. And we know that's a minus 3, which means this guy is going to be left 3 units. And then I come to the outside, and I have a minus 1 sitting out in front. It's in front of the function, and it's on the outside. That means I reflect the x-axis. And now I'm done with the first term, and I come to this last one. It's a plus 1, which means it's going to be up 1 unit. Now, given that to be the case, if I know that I only have, this is the guy that's on the x, the rest of them are on the y, that I know I'm looking at my basic function, which is x, and my basic is 2 to the x. So that's your x and that's your y. Now, how many coordinate points do I need? I only need 3. This is the beauty of the exponential function. I need 3. I need these 3 points right here, because that's the, oh, sorry about that, because that's the bend in the graph. This, once you leave and this guy's heading down, he's going to ride along the HA. And then when you go up, he's going to go away from the HA. So these 3 points would be significant. It's negative 1, 0, and 1. This is the bend in the graph. With that being the case, that says I need negative 1, 0, and 1 on my x's. There's one other thing I need. I need the HA, and it's 0, because the HA will shift. This would be 2 to the negative 2, which is 1/2. 2 to the 0, which is 1, 2 to the 1, which is 2. Now I'm going to go left 3, which means I'm going to subtract 3 or add a negative 3 to all of the x's. That moves everybody left by 3 units. So this would be negative 4, negative 3, negative 2, and the HA is still the HA. It doesn't shift because it deals with y and not x. And then I'm going to reflect the x-axis, that's on the y side, so I'm going to multiply by negative 1. So I have negative 1/2, I have negative 1, I have negative 2, negative 1 times 0 is still 0. And then I'm going to move this up 1, and up 1 I'm going to take negative 1/2 plus 1 is positive 1/2. Negative 1 plus 1 is 0. Negative 2 plus 1 is negative 1. And then 0 plus 1 is 1. My new HA is y equal 1. So on my graph, my new horizontal asymptote is going to be y equal 1. Because the HA got shifted up 1 unit. The domain is still, no matter what, going to be all real numbers. And y, you take a look at 2 to the x plus 3, no denominator on the x plus 3, no radical on the x plus 3. It's all real numbers. Now the range, we're going to have to take a look at our graph in order to do that. I first lay in my HA. And then I put in my new coordinate points. If x equals negative 4, y equals positive 1/2. 1, 2, 3, 4, positive 1/2. If x equals negative 3, y equals 0. This guy has an x-intercept. If x equals negative 2, y equals negative 1. There's your bend right here. Now what do we know? We know that the graph will go away because it's moving away from the HA, and then it's going to go toward the HA. But the bend is critical because it's coming in toward the HA, it's not going to cross it. Now what do I now know about the range? The range is going to be what? Negative infinity to y equal 1. Does not include it because it's an HA. Now you can see these graphs are time consuming because they're very, very, very detailed.